Welcome to Data Science with EJD. In this video, I'll be talking about deploying machine learning models. And of course, as a data scientist, one of your key roles would be to develop models based on data and all of that. At the end of the day, you want to be able to deploy the models for use in whatever situation you find yourself. Not so interestingly, what I'll be doing here would just be like a kind of overview of what you'd be expecting if you need to deploy because of course this is just for educational purposes since I don't have all the necessary facilities because for full deployment you may have to talk about things like Docker, things like cloud computing and all of that. So I'm just going to I'll practicalize where I have to practicalize talking about codes, and I'll just talk about other things I'm not able to handle at this point in time. But of course, to be like a head start for you, if you like, find yourself in an environment where you need to deploy machine learning models for your job. All right. So let's start with what model deployment is about. Model deployment is the process of making a trained machine learning model available for use in a real world environment where it can receive input data and return predictions in real time or batch mode. Now, in the previous video, we used the case of diabetes. We want to be able to predict how diabetes progresses based on certain kind of inputs, right? So if probably you work in a health system where you need that kind of model from time to time, so you need to be able to deploy it such that when anybody comes, you can put their data into the model or something like that and be able to get something that can help you to make certain decisions. That's what deployment is basically about. And the question is, why deploy? So to deploy, you need to deploy to enable real-time or batch predictions for end users or systems. People should be able to come in there and then put in their information. I mean, this can deployment can be in form of apps or web sites or something like that, where people just go input their information and they get something out of, they get some information that can lead them, that can guide their decision making, right? It can also help to integrate machine learning into applications, products, or workflows, just like I just said, and to monitor and improve model performance over time. So as you deploy, you want to see how well your model does. I mean, most of the times when you make an app or you make a website for certain purposes, you need different testing stages where people get to use it in real time and see how useful it really can be. And from that, you can see if there's a problem with your model and that you need to fix or not. Okay. So it can also be helpful to automate decision making or provide insights. For instance, I'm aware that many investment companies they have some kind of online calculator where you just input, maybe you tell them how old you are, how much you earn, what is your goal, and things like that, and then they're able to give you some recommendations on how you should invest and all that. So automation is one big goal of deploying AI, machine learning models, right? So let's talk about deployment workflow overview. Deployment workflow overview. Of course, we talk about the model development. We did something close, something like that in the last video. So where you train and validate the machine learning model, e.g. linear regression that we did in the last video. Then you also have model serialization. All right, model serialization. Here you save the train model to disk like Pickle, using JobLib. I think yeah, we're going to use JobLib in this particular one as we go on, and or you can use ONNX. Then there's also API creation in this situation. Here you wrap model in a RESTful API, for instance, if you're using Flask or Fast API. Of course, some of these facilities are not available to me because I mean I'm just doing this in the role of a teacher, but in a real situation where you need to deploy this, I mean this is a head start for you, right? There's also containerization where you package the API into a Docker container for portability. Then you can also talk about hosting where you deploy container on cloud services. So you see cloud storage and all that is coming into play. So deploy container on cloud services like Amazon Web Services. That I think that's what that is. There's GCP, there's Azure from Microsoft or on premise, right? Then there's also monitoring and update. So you want to monitor your model usage and retrain and redeploy when needed. So as you want to monitor your model to see how it performs, and then you need to make corrections if there's need for that. Maybe there's at some testing stage, people have certain issues that you can correct. So, I mean, we've done something. So, you still talking about the same diabetes prediction model we talked about in the previous video, right? So let's see how we can deploy something like that, for use at the end of the day. So deploying a diabetes prediction model, the first step we want to do is to train and save the model. Now, this we have done before, right? So from sklearn the data set, you want to import the load, you want to import low diabetes. From sklearn linear model, you want linear regression. From sklearn model the selection, you import train test splits, which we use in splitting the data up into the train set and test set. Then you import job lib, which is very good for deploying for model serialization. So of course, everything we did step by step the other time, we're just doing everything in a blow in this situation. So you want to load the data, you have diabetes equals load diabetes, then X is the diabetes data, Y is the diabetes target. This is your target, and so but for the data you have more than one data, more than one column like we saw previously. Then you split the data as usual. This is like a standard thing we keep doing. X underscore train, comma X underscore test, comma Y underscore train, comma Y underscore test. And that is equal to train underscore test underscore split, which you imported here, right? And then you throw in the X and the Y. Then the test size you decide. Mostly we've been using 20% for test. I mean that 80% goes for train set, right? For train size, and the random state is to make sure that you keep getting the same result at the end of the day. Then you want to train your model. So to train the model, just a model is linear regression. So you just have model dot fit the X train, the Y train. So by doing line 15, you've trained the model like that. Now you want to save the model to disk, right? And what you just do, the job lib you imported here. So just have job lib dot dump the model, that this model you have here now. Then you save it as diabetes model.pkl. Then you can also, so you can just say model saved. Now this diabetes underscore model.pkl, it doesn't already exist on my on the where I'm using like my folder. This is the folder where all the data science thing I've been doing is. So you notice that there's nothing like .pkl there right now. So if I run this now, it takes some time. Okay, now it's done, and it says model save. So if I come back here, so now I'll be having diabetes underscore model.pkl. So I think for what we saw the other time, we could actually load this, right? We could just say joblib dot load, and we load this. So let's try that out. Now that this is done, so I could just come and say, so let me create. Okay, escape B. Yeah. So I could just bring this. Yeah. So, but instead of dump, right, I just do load. Okay. Just say load this. I guess this is not needed from what we saw the other time. We don't need this. So I run this. So, I mean, so with this now, it has mounted that linear regression model thing. So okay, I mean, here, this is not documentation for linear regression fitted. So, so we can load it like this. Okay, so if you open it now, it takes you to the documentation for what you've done. Then for the fitting, uh, okay, okay, yeah, there's more we can do with this later. So, for use, you can have all of this. Okay. So in step two, you want to create a simple API with Flask. Create a simple API with Flask. Now, Flask uh, is a Python library, right? That we use for things like this. Um, by the way, API itself is actually it's an application that helps you to make certain connections or trying to application programming interface. Yeah, so you have an application programming interface where you can actually say where you can do certain tasks. But just like I said, right, I don't have all the facilities necessary for a full deployment, but I mean this can give you idea into what deployment is all about, right? So we are creating a simple API with Flask. So from Flask, you want to import Flask with capital F, then request JSONify. Then you want to import NumPy as NP. You want to import job lib. You want to import sys. Then the app. So you initialize the Flask double underscore name double underscore. Then you want to attempt to load the model just like what we did here now. So this is us loading the model right here. So you try model equals jump_load diabetes underscore model.pkl. Then you print model loaded successfully if it's loaded. Then except if that doesn't happen, so you can give an error. So error model, then it tells us why that error is there. Then we have this app.root predict method post, then you make a function to predict. So you try JSON data from post request. Data is request dot get JSON false true. Then you want to extract features and reshape for prediction. So features NP array, data features, reshape one minus one. Then predict using the model. So you want to make predictions with the model. Then you return the prediction as JSON. So you return JSONify prediction, and then you have a JSON file which you can read, uh, and then accept JSON as E, so return JSONify error. So if name is this, so after all of that, then you can run the Flask app in development mode. So if I run this whole thing now, it works, and then it says model loaded successfully. So 7 Flask app main debug mode is on. So of course, and we also have some warning. So of course, that doesn't mean that it's not working. It's just telling us there are things we need to pay attention to. This is a development server. Do not use it as a production deployment. Use a production WSGI server instead. So running on HTTP 1227, blah blah. Press Ctrl C to quit. So we're starting with Watchdog, blah blah. An exception has occurred. Use this to see the full traceback. So I mean, just because I don't have the whole facility required, that's why we have all this. But let's see if something else has been added to our folder here. Okay. Yeah, this is the only thing we still have so far. Nothing is added. Okay. Yeah. So we have the but when you have the whole facilities, you can actually see all of that. But at least model loaded successfully. So how this works is that the programming interface, right? The application programming interface listens for post request on and slash predict, and client sends a JSON payload like feature 0 point. So it sends all these feature values. Then the application program interface, right, now returns the predicted diabetes progression value, right? That's how the deployment occurs. So if you test the API locally, you can use curl or postman to send a post request. So like I don't have all the whole facility, right? So expected output to be something like prediction 151.52. So this gives you a value for maybe a particular situation which you can actually use. So in step 4, you containerize the API with Docker. So with the Docker file, you have all of this. So Docker is it's not something beyond this, which I'm not ready to go into right now. I'm just, it's more like me giving out the information for those who want to go all the way. Like maybe you find yourself in an industrial setting where all of this is necessary. So these are some guides you can follow. Then you can also build and run with the Docker. So build T diabetes predictor, blah blah blah, and all of that goes. So in step 5, you can deploy to cloud or product environment. So I talked about cloud, right? So you need some cloud computing or and things like that. So you want to upload the Docker container to a cloud service like AWS, ECS, Google Cloud Run, Azure Container Instances, or a Kubernetes cluster. So I'm not I'm not really into all of this, right? So you want to set up load balancing, scaling, and secure HTTPS endpoints, add authentication and login for production readiness. Of course, if I find myself in an industrial environment, definitely I'll be open to uh, delve into this. But the beautiful thing is that in most industrial situations, right, you have data engineers, data architects already setting the infrastructure in place. So you as a data scientist, all you just need to do is, develop your model, and then you are guided on how to connect with the pipeline or whatever has data infrastructure has been set up for you, right? 5.5 monitoring and retraining. So you can track model performance like prediction, latency, accuracy, drift. You can collect new data and feedback to identify performance degradation. So you can schedule retraining and redeployment pipelines using CI/CD tools. So use tools like Prometheus, Grafana, or ML machine learning monitoring platforms like MLflow, Seldon, and Cortex. Okay. I mean, even for me, some of these things are pretty new. But if you're in that space, you can actually make sense of it. Or if you get into that, if you find yourself in that space, I mean, this is an introduction into all of these things, so you can get ready, right? So advanced deployment concepts include things like batch prediction, where you run model on large data sets offline for reports. So of course, in an industrial setting, you need to give reports of model performance, the kind of results you're getting, and things like that, because you have to monitor your model. So model versioning, so you have to manage multiple model versions, rollback if needed. So just like in the case of a database, right? You want to have markers like you want, in case you are not able to, something goes wrong with your database, you want to be able to go back to a particular point where everything was working fine, right? So your model, so if you change it, maybe you added something or you moved something, you want to be able to know, oh, that was the model as at yesterday, but by this time, at this particular time when we worked on it, this is what we now have, and things like that. Then there should also be explainability. So you want to integrate explainability tools like Sharp or Lime to interpret predictions. So for security, like, right, you want to secure application program interfaces with authentication, encryption, and rate limiting. So you don't want anybody to hack into your system or things like that. So you want to take care of your security. Then there's also serverless deployment where you can use AWS Lambda or Google Cloud Functions to for lightweight prediction tasks. Okay, so our summary table. Um, so we have deployment storage, tools and technologies, and the description relevant to them. So for model training, we have scikit-learn, TensorFlow, and PyTorch. So we use this for model training. So for the most part, we'll be using scikit-learn. So as we go deeper, we may have to use TensorFlow and PyTorch for other machine learning duties or even deep learning, right? So here you develop and train your model. So for serialization, you can use JobLib. In fact, we've used JobLib so far. You can use Pickle or ONNX, and so this helps to save trained model artifacts. So you have application program interface development. So there maybe you're already beginning to talk about some UI UX kind of thing. So here you use tools or technologies like Flask, Fast API, Django, and then you create REST API for predictions. Then for containerization, you use Docker where you package API and dependencies. For hosting, of course, like in the cloud, you need things like Amazon WS. I've forgotten what that is. Let me be sure. AWS. That I know A is Amazon something. I need some cloud thing for sure. AWS. Yes. Amazon Web Services. Yes, Amazon Web Services. And there's GCP, there's Azure, there's Heroku, Kubernetes. And with this, you run model service in production. For monitoring, you can use things like Prometheus, Grafana, machine learning, MLflow. Then, so you can use it to track performance and usage of your model. Then for automation, you can use Jenkins, GitHub Actions, Airflow to automate retraining and deployment. Okay. So final notes: deploying machine learning models transforms your experiments into actionable tools. The diabetes model example shows the entire cycle. So I want to break this up for easier handling. Say, okay, um, yeah. Okay, so the diabetes model example shows the entire cycle, just like we saw before. So you train on clinical data, you save the model artifacts, you build an application program interface for external use. You package and deploy to cloud infrastructure. You can monitor and improve continuously. And this process enables data-driven decision making in healthcare or any other domain where machine learning adds value, right? So you can apply it in financial services, in healthcare, like we've seen, or in education, in whatever sphere you are interested in applying that. Thank you so much for listening. Let me know how helpful this video is for you in the comment section. If you have subscribed, thank you so much. If you have not subscribed, please go ahead and subscribe. And do not forget to hit the notification bell so you can always get alerted each time a new video is released. Right. My channel now has membership, so you're free to join to get some extra privileges. Of course, feel free to also like and share so that more people can have access to this channel. Till I come your way again, keep doing data right. Bye.